Myself, Dr. P.R. Krishnaveni, Associate Professor of Chemistry, Sasi Institute of Technology and Engineering, Tadapalligooda. Welcome to the lecture on lubricants. Lubricant is a substance that helps to reduce friction between surfaces in mutual contact, which ultimately reduces the heat generated when the surfaces move, and this phenomena is known as lubrication. So this is a lubricant. So when this lubricant is applied between two surfaces which are in mutual contact, it reduces the friction. Next, classification of lubricants. On the basis of physical state, lubricants can be classified as lubricating oils or liquid lubricants, greases or semi-solid lubricants, solid lubricants. Lubricating oils or liquid lubricants. These lubricating oils provide a continuous fluid fill over the moving or sliding surfaces. They also act as cooling and sealing agents. And the examples for these lubricating oils are vegetable oils, animal oils, mineral oil, and blended oils. So this is the example for lubricating oils, and these are the blended oils. Next, greases or semi-solid lubricants. A semi-solid lubricant is obtained by combining lubricating oil with thickening agent like soap is termed as grease. Examples: soda-based greases. Soda-based greases means, in this case, soda soap is used as thickening agent. It is used as thickening agent in petroleum oil, these soda-based greases are slightly soluble in water. And they can be used up to a temperature range of 175 degrees centigrade. Next example is lithium-based greases. In lithium-based greases, lithium soap is used as thickening agent. How means? It will be emulsifying with petroleum oil. These lithium based greases are resistant to water. They can be used up to a temperature of 15 degrees centigrade. Next example is calcium based greases. In calcium based greases, calcium soaps are emulsified with petroleum. These are also resistant to water. These can be used up to a temperature of 80 degrees centigrade. At high temperature, calcium soap and petroleum, these will separate. Next, axle greases. These axle greases are very cheap resins. These are formed by adding lime to resin or fatty acids. These are formed. In addition to lime, we can add filters also. Filters means talc and mica. These axle greases are useful for delicate equipments that bear heavy load and move at low speed. Next, the third type. So these are the examples of semi-solid greases. Solid lubricants. These are used either as dry powder or mixed with oil or water. Examples for solid lubricants are graphite and molybdenum disulfide. So this we can easily understand by observing the structures of graphite and molybdenum disulfide. If we observe graphite, already we know that graphite is a good thermal conductor Mainly it is a good electrical conductor. This we have learnt in refractories. Coming to the structure, graphite has layered like structure. It has layered like structure. These layers are held together by weak van der Waals forces. As they are held by weak van der Waals forces, these layers can easily slide one layer over the other. And this graphite can be used as powder, or as mentioned here, it can be used by mixing with oil or water. This graphite can be used up to a temperature range of 450 degrees centigrade. A next example for solid lubricant is molybdenum disulfide. Molybdenum disulfide means structure is MoS2. So this is the structure of molybdenum disulfide. So already what I told you the structure, MoS2. This will be existing as sandwich. That means the hexagonal layer of molybdenum is sandwiched between the hexagonal layer, two layers of sulfur. Same like graphite, these hexagonal layers are held together by weak van der Waals forces. So unlike graphite, this can be used in high vacuum. Unlike graphite, can be used under high vacuum. This can be used at a temperature of 400 degrees centigrade. And the common point for graphite and molybdenum disulfide is same like graphite. Molybdenum disulfide hexagonal layers are also held together by weak van der Waals forces. Next, coming to the mechanism of lubrication. The mechanism of lubrication is of three types: fluid film or hydrodynamic lubrication, boundary or thin film lubrication, extreme pressure lubrication. Coming to thick film or fluid film or hydrodynamic lubrication. This is generally carried with the help of lubricants. In this mechanism, two moving or sliding surfaces are separated by a thick film of lubricant fluid of about 1000 angstroms applied to prevent direct surface to surface contact and consequently reduces the wear and tearing of metals. In this case, fluid is formed by mixing of hydrocarbon oils and antioxidants with a long chain polymer so as to maintain viscosity. So here hydrodynamic we are using. The term hydrodynamic means, hydro means liquid, dynamic means relative motion. That's why in this mechanism, two moving and sliding surfaces will be separated by a thick film of lubricant fluid. So see here. So this is a figure which shows the thick film lubrication. Here the two moving surfaces, see, which are moving with this velocity. And this is separated by a thick film of lubricant. So this is the lubricant. While it is moving, see here, this is the bearing line, and we have applied the thick lubricant here. So this what it shows, the rotating shaft and floating. So because of this we can maintain the viscosity of the fluid. Next, second mechanism. Second mechanism is thin film or boundary lubrication. It is carried with semi-solid, that means what? Grease, and solid graphite and molybdenum disulfide lubricants. Boundary lubrication is a condition in which the lubricant film becomes too thin to provide total separation. In this type of lubrication, a thin film of lubricant is adsorbed on the surface by weak van der Waals forces. So see here, this shows about the thin layers of the lubricant. So these are the thin layers of the lubricants. And these are operated at low speed and have heavy loading. Heavy loading means under high pressure. See, from this figure it is clear. Low speed and high force surfaces are together. Here we have the thin lubricant film. Next, coming to the third type. Extreme pressure or temperature lubrication. In this mechanism, moving or sliding surfaces are under high pressure and speed, and hence known as extreme pressure lubrication. High temperatures are generated due to friction. So liquid lubricants fail to stick and decompose or vaporize. These problems are minimized by adding special additives or oils. These additives form durable films on metal surfaces which can stand high loads and high temperatures. So here additives we are saying. Here additives means these are the organic compounds with groups like sulfides, chlorides, phosphorus, nothing but phosphates, etc. So these additives react with metallic surface to form metallic compound like chlorides, sulfides, sulfates and more durable film. Why? Here additives means what? Nothing but the organic compounds which contain the groups like sulfides, chlorides or phosphorus. So see here, this is before load and this is after adding additive. In the next lecture, I will tell you about the properties of lubricants. Thank you.